their centers is 10 centimeters. So the resulting repulsion of A is noted. Spheres A and B are touched by uncharged spheres C and D respectively. So if these are having the spheres QQ, okay, so they are of identical sizes, and what is expected out of them? See, both are having the charges QQ. Now C is uncharged, means C has the charge 0, D has the charge 0. So if you remember, I told you in charging by conduction. In charging by conduction, I told you that when two charges are present and they are having contact, so the new charge after contact is given by Q1 plus Q2 divided by 2. Remember, in charging by conduction, we did this. Are you both present today?
Yes, ma'am.
Okay, where is Tayyiba?
I'm here only, ma'am.
Okay. So see, if charge Q is here and this is 0, what will happen? The charge distribution will be C, Q plus 0 by 2, that is Q by 2. So it means this A becomes Q by 2, B becomes Q by 2, and their separation is reduced by half. So what will happen? Initially, the force was K Q1 into Q2. See, this is how we write the formula of force. K Q1 Q2 divided by R square. This is how we write. So here both the charges are same because bodies are identical. So Q into Q by, initially it was, let's say this is R square. So force was K Q square by R square. Initial condition. Now what has happened? Charges have been divided by 2 because of conduction. Here charging by conduction has occurred here as well as here. So now what will be the new force? Look, K Q by 2 into Q by 2 divided by, see, distance is now 5 centimeter. Initially it was R, that is 10. Now this is 5, which is R by 2. So this will also become R by 2 whole square. So look, this is again giving you K Q square by R square only. Means the force will not change even after all this. Got it? Even after the 4, see, this 2 will cancel the denominators 2 and 2. 2 square is there. Here also you have 4. So you are getting K, Q into Q, that is KQ square by R square back. So even after doing and performing all these things, your charge is not getting changed. Is that clear?
Yes, ma'am.
So just write down this part so that it is there with you. Done?
No, ma'am.
Completed?
Yes, ma'am.
Look, the second and the third question are exactly the same as the first one. See, this is what was there. Two similarly equally charged metal spheres, they are present, they repel each other with this force. A third uncharged sphere is touched and it is placed in the midpoint. So if you have two spheres that are present, okay, these two spheres are existing and they are repelling each other by a force F. So if this is the case, then see, once you have this as first sphere Q, this is another sphere Q. Now, as soon as C is touched, what will happen? Again, this will become Q by 2 and this will become Q by 2. So it
Yes.
says A is like this, Q by 2, C is like this, Q by 2, and then C is touched to A, yeah. And see, C is placed like this in the midpoint of A and B, but B is still Q. So this is what it is saying, net electrostatic force on C. This you have done it in superposition principle already, how to calculate the net electric force. One force will be from this side, this one will be the force, and one force will be due to this. And it's in the midpoint, so separation is also clear, R by 2, R by 2. Like this you need to calculate. And what it is equal to? It is equal to the force 2 into 10 to the power minus 5 Newton. Got it? How to solve this?
Yes, ma'am.
So it's based on this conduction only. And yeah, one more thing, Hadia, your magnitude part was right, position was right. You didn't write the sign. You have drawn the figure and everything. You didn't write finally which sign you are concluding. Like if your sign was negative, you didn't write that you are getting a negative sign, that or you want a negative sign. You didn't show the negative sign. So just when you have the signs also, no, that time show that yes, you want a negative sign or a positive sign. Okay.
Okay, ma'am. Okay.
All right. Can we come to our class?
Yes, ma'am.
Okay. See, I have to start with electric field. Now understand what is the meaning of electric field. This is not difficult. It's a simple, easy topic. Look, if I have a charge, okay, I'm having this charge plus Q, and I have brought another charge, let's say small q. Now I'm bringing this charge here, nothing is happening. Then I brought this small q here, nothing happened. Then I brought this small q here, nothing happened. Nothing happened means I couldn't experience any force or I couldn't see anything. Around this capital Q, there exists a field which we called as the electric field. If you step in here and as soon as you touch this here, what happens? As soon as you see this Q present here in this sphere, it will experience the force of attraction or repulsion. This charge which we are using in order to check our experiment, to perform the experiment, it is called as the test charge. Means you are testing, so that's why test charge. And this is creating the electric field, right? So this is the source charge. It's the source of electric field. So we say this is the source charge. Now this space around every charge, see, whenever any charge is present, you have plus q, minus q, any charge. Around it, there will be a field present. Here only the electrical properties will act. Around this charge only the electrical properties will act. If you are putting any charge here or here, anywhere here, minus q, plus q, anywhere here, you won't be able to feel anything. As soon as you touch it inside this field, you'll experience electrical properties. Why? Because see, positive will repel. If it is negative, it will attract. So that is visible when you have the electric field present. So this space around the charge particle is called the electric field. So space around charge in which its electrical properties can be experienced. And see, it is used to explain the non-contact forces, right? You are not bringing anything in contact. So it's a property of a single charge. Means if you see, when we were doing the Coulomb's law, you required Q1 and you required Q2. When both of these were present, then only you could apply the Coulomb's law. With a single charge, is the Coulomb's law valid? No, you have the formula K into Q1 into Q2 by R square. So the whole formula is not valid. So electric coulomb means coulombic force, electric force is existing when two charges are present. But if you just have a single charge present, around it there will be a field which will be existing, and this field is called the electric field. So it's a property of a single charge, means you do not need another charge for this electric field to exist. If you, even if a single charge is there, around it this electric field will present, and electric field travels with the speed of light. The speed of light is 3 into 10 to the power 8 meter per second. Did you understand, both of you, this part?
Yes, ma'am.
Okay, write it, then we'll see what's the formula of it. Write it, just text me done in the chat column as you are doing it, so I'll scroll it then accordingly.
Okay, ma'am. Done, ma'am.
Okay, see now for calculation of the electric field due to a point charge. So see the way we had the Coulomb's law for calculation of point charge, 2 point charges were there. So our formula was 1 over 4 pi epsilon naught q1 q2 by r square. Now see, if you have a charge present, we often have the formula of electric field as C, force divided by charge. Okay, this is the first formula of electric field. We will see this due to a point charge, we will see. So see, electric field is force by charge. Now, what is meant by this limit q tends to 0? This you will find it written in your textbook. This basically means that the magnitude of q is very less. It's very less. Because otherwise, if the magnitude is very high, it will disturb this and we will not be able to get the electric field properly. We were just doing an experiment before to test whether electric field is existing or not. So if we have the value or magnitude of the small q very much, so what will happen? If the value is very much, this will also produce force and both of them will just produce force and repel each other. So we'll not be able to test. That's why the value of this q is taken very small, limitation q tending to 0. This is what is meant by this. Is that clear till here?
Yes, ma'am.
So see, electric force experienced by test charge plus q due to field of source charge plus q is the electric field intensity. Means this is what is the formula of electric field intensity. In your exams, electric flux density is usually not given. Electric field strength is given and electric field intensity. These two terms are given often. So if you see electric field intensity, just use the formula E is equal to F by Q. So from here you can say force is equal to charge into electric field. If needed, you can use this formula anyway. So this I have told you, force experienced by Q is negligible, hence Q cannot be. Now if Q is stationary, see if the source charge is stationary, then only we'll be able to perform the experiment. So this was done to analyze what is basically electric field in this component. Here, when you are testing it, for this component, that part was done. This value is very small. The value of this charge is very small. So that this is at rest and we can analyze where the electric field is present. Even is there any electric field present or not? So electric field is a vector quantity class. Direction is the force experienced by test charge. Now, what is the direction? This I will tell you properly after this. Electric field is a vector quantity. So you need to use the vector laws. You cannot add it. Vector laws means which laws? Vector laws. Parallelogram law, triangle law, polygon law. The vector laws means parallelogram law. So you have to apply the parallelogram law. Okay, SI unit is Newton per Coulomb and you will sometimes see volt per meter also. But don't do it right now. When we'll do the chapter electric potential and capacitance, that time you will understand why one more unit is volt per meter. Right now you just remember, see, forces SI unit is Newton, charges unit is Coulomb. So Newton per Coulomb, this is the SI unit. Is that clear?
Yes, ma'am.
Write it till here. Then we'll discuss some more properties or just one more thing. Class, tell me, if in the formula F is equal to or E is equal to F by Q, if I put the value of charge as 1, means 1 coulomb, what will be left in this formula? Can you tell? If charge is 1, what will be left in the formula?
Force.
Yes, force. Means if your charge is plus 1 coulomb, then you can say electric field is exactly equal to the electric force. It means how can you have now one more definition of electric field. Electric field at a point can be defined as force experienced by unit positive test charge. Unit means 1. Unit positive test charge. So You can sometimes say electric field is equal to the force. So in short, what is electric field? When a charged particle is present, around that there's a field present where electrical properties are existing. You can bring another charge to check whether the electric force is actually existing or not. Like similarly, you will see the same thing in magnetism. Magnetic field will be present. Have you seen if two magnets are brought closer to each other, even at a distance, they are able to get attracted. You don't need to just make them properly in physical contact. Even if they are at a distance, they get in contact because of the magnetic field. Similarly, here also you have an electric field. It's just that charges are not visible to us, so we are not able to experience it. But mathematically, we can show by this formula. Is that clear till here?
Yes, ma'am.
Okay. Write it if you want to ask anything. Let me know. From here, please write it.
Okay. Done, ma'am. Done, ma'am.
Done?
Yes, ma'am.
Okay, let's see a question. This says a test charge of 10 to the power minus 3 coulomb is there, it experiences a force of 10 to the power 2 Newton due to field of a source charge. Calculate the magnitude of the electric field. So see, what is the formula that we have studied before this? Force is given as 10 to the power 2 Newton. Charge is given as 10 to the power minus 3
Ma'am,
coulomb.
it's E is equal to F by Q.
Yes, right. E is equal to F by Q. You have to calculate electric field. So force is 10 to the power 2 by charge is 10 to the power minus 3. So minus 3 will go up, 10 to the power 5 Newton per coulomb. Clear?
Yes, ma'am.
Write it quickly. Then we will see how to calculate for a point charge.
Done, ma'am.
Okay, now let us see what is the formula due to a point charge. We know due to force. If force is given, we'll be able to calculate like in the previous question. What if force is not given? Then how can we calculate if we just know the charge and the distance? So for that, we are using, firstly, we are using the Coulomb's law. So can you tell me what is the force here? Apply Coulomb's law, tell me the force. How do we start? This is one charge, this is second charge, and they are separated by distance r. Yes, how do we start with it? Coulomb's law.
Ma'am, is it going to be like is equal
Yes.
K into Q, capital Q
Q1, Q2 upon R square.
Yeah, that one was right. Capital Q into small q by r square. Because we are specifically talking about this, no? When you have general, Q1, Q2 is just for general. What is Q1, what is Q2, that you have to decide. So correct? K into capital Q into small q by r square. This is our Coulomb's law. So Coulomb's law has given us the force. And what have we seen just now? Electric field is F by small q. Let's put the value of force. Force is K, capital Q, small q by r square. And this small q. Look, small q got cancelled. So what is the value of electric field? It is K, capital Q by r square. Or this can be written as 1 by 4 pi epsilon naught capital Q by r square. What is r? R is the separation of the charge to the point of calculation. Like if I want to calculate at P point due to this will be having its electric field. So I want to calculate it at P point. So I'll take this as r. R is the separation that is given. And remember, direction I was telling you, let me tell you the direction. Remember, for positive charges, just move away from the charge. Wherever is the charge located, just move away from it. See how you have to apply it here. Like this. This is a positive charge and this is point A. So if I move like this, it will be towards. So I'll move like this. This will be away. Or if you see, this is point B. If I move like this will be inwards. No. Positive charge, we move away. Can you tell me direction for C? Right, left, up, down?
Ma'am, it will be up.
Correct. Because we'll move away. Similarly, for D, it will be downwards. And just reverse this for negative charge. Move towards the charge. Like if charge is here, if I move here, so it will be away. So now I will move like this if it's a negative charge. Similarly, for B, it will be here. C, it will be towards. For D, can you all tell?
Down. Upwards.
Upwards. It will be upwards towards the charge. Okay. And remember I told you that electric field force for air is 1 over 4 pi epsilon naught q1 q2 by r square. But as soon as you had the medium, we discussed the dielectric constant also, and we discussed that here we'll put and multiply it with k. So here also, if you have the medium like this, you can use 1 over 4 pi k times epsilon naught q by r square. Same for the medium, the way we have done. Also, if you remember, we have discussed that force in the medium, force in air by dielectric constant. Similarly, electric field in the medium will be electric field in air divided by this dielectric constant. Is it clear?
Yes, ma'am.
Okay, write it till here, then we'll see a question. This sometimes come in the exam. Taiba and Hadi, I'm just coming in a minute.
Okay. Done, ma'am.
Okay, look at this question. This says a point charge of 10 coulomb is placed at the origin. Okay. Then it is saying calculate the electric field at a point A, which is 3, 0, 0. Now, when it is saying A 3, 0, 0, this means this is in coordinate form. So this is X, this is Y, this is Z. Means y-axis is 0, z-axis is 0. So you just have to locate the point at x-axis. So this is the charge 10 coulomb and here is your point A. So from 10 coulomb to A, you need to calculate. So first you both try it by yourself. Send me the answer in the chat column. After 2 minutes, I'll discuss it myself with both of you. At least try it once. One more thing, you both have the exam on the 11th of May, physics exam.
No, ma'am, it's 19th of May.
19th of May. Okay. First chapter is coming and second is coming and
Third one.
third one till current electricity is coming. Okay. So 19th, yeah, 2 chapters will be done. We'll be on current. Do you need any extra class on Friday?
Yes, ma'am.
Yes, ma'am, you can have it.
All right. So let's have class on Friday then. Are you both available?
Yes, ma'am.
We can have the class from 6:30 to 7:30 or 8 o'clock. 1.5 hour class let's have. It will at least cover the syllabus.
Ma'am, KC timing?
No, no, no. This is IST. Check for the Saudi timing. Is it
Wait.
matching? Is it fine? Okay, discuss and let me know the timings for this Friday. Okay.
Okay.
Friday, let's have one extra class then. this timings, just confirm, both of you. Talk to each other, talk to your mother. Let me know what's the timing that you prefer. This is my preferable timing. Just check if it is suiting you. Otherwise, let me know. And one more thing, class. Do you have your school's previous year paper? Like your seniors must have had the unit test which they have given last year, or the school's question papers of pre-boards or anything. See, I have for CBSEs, no, but particularly for your school, that I want. So, do you people have? Have you talked to your seniors or anyone?
Ma'am, no, like for the board paper you're asking?
No, board papers. So see, board papers I have. The see right now the UTs that will be conducted, the periodicals which will be conducted, and the half yearlies that will be conducted, and till the pre-boards, and the UT, your school will be conducting everything, right? So your school's previous year's papers on these. Board's paper is standardized. Board's pattern and everything I know. I just want it for your school so that I can prepare you accordingly. What are the kinds of questions that come? Which questions are repeating, or any idea? Even one paper if you can get. Talk to your seniors. Somebody must be there.
Okay.
Yes, ma'am, but actually, our last year 12th grade seniors are like, they already gave their board exams, so like they don't even come, so like it's really not easier for us to contact them and so on.
Okay, so okay. They are not in contact with any, so you don't have the papers.
Yes,
Ask
ma'am.
your teachers if they have any. So
No,
it will give you an idea, because see, for board exam I will prepare you perfectly, but for your these periodicals and in between that come. What is the name of your school?
International Indian School, Jidda.
International.
Indian School, Jidda.
Okay, International Indian School. Okay then. Okay. And just let me know the timings also apart from the question.
Yes, ma'am. In IST 6:30, in case it will be 4 o'clock. So I think we are available at that.
You are available?
Yes,
Okay.
ma'am.
Okay, let's have this class then on Friday. Okay. So it will be 4 p.m. Yes.
Ma'am, it will be 2.5 hours class, right?
No, 1.5. No, 6:30 to 8.
Ma'am, actually,
So 4 to 5:30 for you.
yes, ma'am.
2.5 hours will be very much. Means you'll not be able to then grasp after 2 hours. It will be difficult. So that's why we can have the class then next Friday. And after when you people have the vacations in July and all, no?
Yes, ma'am.
This whole month is working. C class. This point A is located at 3 meters from the origin. Did you get any answer?
Ma'am, I got
How much, Taiba?
9.
9. Okay, let's check. See, this is saying A point. We are going to calculate the electric field at A point. So formula of electric field due to a point charge is K into Q divided by R square. Now K is 9 into 10 to the power 9. Charge is given to us 10 coulomb, which is placed at the origin. So this is into 10 divided by. See, separation is 3 from the point charge to the point of calculation. The separation is 3. We write 3 square. So see, this will become 9 into 10 to the power 10 divided by 9. 9 gets cancelled. 10 to the power 10. And look, this is a positive charge. So electric field will be where? Towards the charge or away from the charge?
Away from the charge.
Away from the charge. So this will be like this. And this is our x-axis. So we can write I cap, this much of Newton per Coulomb. So this is how we have the direction and magnitude. Got it?
Yes, ma'am. Now,
Yeah, थे ये बसे?
how did you consider 10 to the power 9 and
This one.
yes, ma'am.
K's value is 9 into 10 to the power 9.
Yes.
This 1 over 4 pi epsilon naught, which is K. Its value is 9 into 10 to the power 9. That's why. Okay.
Done, ma'am.
Okay. See, the way we had superposition principle in the case of electric forces, here also you will apply the same superposition principle. Means if I have a point charge, let's say this is plus Q1, and I am having one more charge, let's say plus Q2, and one more charge plus Q3, and so on, let's say till nth one, Q nth charge is there. This is the point P where I have to calculate the charge point P. Now look, these charges are separated at the point P. Now I don't require another charge here. I just want to calculate the net charge over here. So this is how they all are separated. So see here, this is R1, this is R2, this is R3, and so on, R4, R5, R6, till Rnth. N means any number. If N is 4, then 4 charges. N5, 5 charges. Now, you know how to calculate, the electric field due to point charge. So if I say Q1 is there, R1 is there. So electric field 1 will be K Q1 by R1 square. Similarly, if the point is here, Q2 is here. So E2 will be K Q2 by R2 square. Similarly, when this point is here, this is Q3. So E3 will be K Q3 by R3 whole square. Like this, for nth amount of charge, we can say K Q nth by R nth whole square like this. So ultimately what you will do, you will calculate individual electric fields like this. But the net electric field will be given by the vector sum. You will calculate it vectorically. Parallelogram law and all you will apply, and finally whatever is the value, that will be the net charge. Okay, so this is saying for a system having n interacting point charges, net electric field at a point is the vector sum of the field due to individual charges. So we'll see questions that will give it a little bit clarity. And superposition is the same. You calculate individual electric field, you add it vectorically, apply your vectors. So for this, again, you need to revise your vectors once. So keep on revising the vectors. Okay. Write down this page. This is clear to both of you?
Yes, ma'am.
Okay, write down this page.
Done now.
Okay, we discussed a concept where net electric force we used to calculate zero. So see that point where you can get the net electric field or electric force zero. Suppose two charges are present. This is Q1 and Q2. Let's say at this point, let's assume that net electric field is zero due to this also, due to this also. So this point, this is called as the neutral point. So sometimes the questions will mention neutral point directly. Sometimes you just have to identify by yourself. So point at which electric field of individual charges cancel each other. Like look at this question. It is saying we did a similar question in force. Now I'm doing the same question in electric field. This is two charges plus E and plus 4E. They are separated by a separation A. Total separation is A. At what point on the line joining the two charges, net field is zero? Means let's say we have a point, random point I have taken. Now I want to figure where the neutral point will lie. Let's say this is the neutral point. Means electric field due to this side will be equal to electric field due to this side. Let's say this is at X separation from plus E. So if total is A, this is at X, what will be this distance?
X minus 2.
R minus X.
A minus X, yes, not R, A is given here, correct. A minus X, see total is A, X you have taken out. So A minus X will be left. Now at neutral point, the electric field is zero. So what we can say, electric field due to this side is equal to electric field due to this side. Now let's talk first for the plus E charge. Taiba, can you try the electric field at N due to E? How should I write it?
Ma'am, it will be
What is the electric field due to a point charge?
F by Q.
Not F, because F is not mentioned, no, every time. We discussed electric field due to point charge.
K into Q upon R square.
Yes, K into Q by R square. Now apply the same thing here. This is N point. I want to calculate electric field due to this. What shall I write?
X plus X into 4.
No, this is the point N. This is the charge E, and they are separated like this. So apply this formula. How should I start?
Ma'am, it will be X into 1.
No. See, what is this?
K into 1. It will be K into
K into what?
1. I mean, positive 1.
E it's given the charge. The charge is E. You know E's value 1.6 into 10 to the power minus 19. So this is not negligible. E we will write. So we'll write E then divided by
X square.
X square. Correct. Hadia, tell me for this one, 4E at this point N.
K into 4 upon A minus X whole square.
For E you will write. E is the electronic charge. Divided by?
A minus X whole square.
Yes,
Whole square.
minus X whole square. Correct. So see, K will get cancelled. E will get cancelled. So what are we left with? 1
X
by
square.
X square is equal to 4 by A minus X whole square. Let us take the roots on both the sides. So this will become 1 by X. This will become 2 by A minus X. So let's cross multiply. Let's bring this here. Let's bring this here. A minus X is equal to 2X. So A will be equal to 2x plus x, which is equal to 3x. So a is equal to 3x. So x is equal to a by 3. This is the answer. It means it is at a by 3 from, I have to always mention, from plus e charge. Got it? How is this?
Yes.
So it means this is at a separation of a by 3 from this. So if it is at a by 3, a minus a by 3 will become 2a by 3. This part will become 2a by 3. So whichever charges has been asked, you write it. Okay, write down this.
Ma'am,
Yes.
ma'am, how did the sign over here change from 4 to 2?
Oh, we have taken the root. 1's root is 1. X square's root will be x. Root 4 is 2. Root here will be a minus x. Whenever something is to the power square, like x square, and you put a root here, root means the power is again half, so this gets cancelled. So root x square means x only. So root 4, similarly root 4 gives us 2. That's why we have put here 2. Got it?
Yes, ma'am.
Done, ma'am.